Hello. So this is actually take 2 of this video. I put a noise gate on the microphone and that completely broke everything. I might have to re-record some audio for the last video. Or I might just play it in high speed for laughs. Anyway, basically, this video is about my questionable decisions. Initially, I was going to build the circuit on this Vera board. It's quite nice. It's got a place for an IC. It's got separated tracks. You can run resistors across. It's got these that look like voltage rails but aren't because they're all connected. I suppose you could use them as a ground rail. That would probably work. It's fine. But then I thought, what if there was a local company could help me out here? So I went and Googled, as one does, and I found, let's get this up, these guys. Now these guys, you send them basically a PDF, and a PDF is really decent if you think about it. PDF of your board, like, there we go, you can see my mouse now, like this PDF board here. They have some software that finds holes, and didn't get it quite right on mine, but it's close enough. And then basically they print it and they send it to you almost the same day. Quite impressed with that. As a new customer, signing up was relatively easy. They had no... I had to tell them my software. I wonder what they make of that. They had no... problems with it. They welcome enthusiasts. Shipping came through. I ordered the boards on Friday after a little bit of back and forth because I messed up the design. They have some design rules. By the way, if you do use these guys, be careful to check these, because you'll find that you might wind up in a photo plot, which is a lot more expensive, and in my case completely unnecessary. Would have been a waste of money. So these small production runs, they've got some good info on their site. They also do etched aluminum or aluminium, if you're sane, and they deliver. Not cheap for a prototype run. For what I paid, which is about 550 Rand, I only get 2 boards. I only need 2 boards, but it's beginning to make the project expensive. That being said, I do like the creature comforts of it. So I'm just going to now briefly go through how you get a board. I'm using a piece of software called KiCad, which is absolutely brilliant. I used it as the main design software for my engineering degree final year project, my honors degree, and it did exceptionally well. I used toner transfer, and then I etched the boards myself. It was okay. I might have been forced to over etch them a bit, and you know, you get the odd broken track as a result of I had to have quite thin tracks. It was quite a complex project, but KiCad worked extremely well for it. So KiCad gives you a user interface about like this. You can edit your schematic, symbol editor. There's a PCB layout, footprint. You can make your own components, calculators, page layouts, stuff like that. It was all pretty decent. So what you do basically is you put together your schematic into the software, and you'll notice this is very familiar. I've added an LED to indicate when the load is on, and I've added an LED that, because I did this in a hurry, I didn't really think it through, will come on when there's voltage on this test point. In reality, I want to invert it. It should come on when there's no voltage on the test point. I think I can probably do that. I'll think about it. You'll notice none of these resistors have values here. But basically, once you've plonked your circuit in, you can find place symbols. That's going to take a minute. Oh, it's not capturing that window. But basically they've got a wide variety of symbols. You place them from there. You can place power and wires and stuff like that. You get it all together, and basically then you go up here and generate a netlist. Once you've generated the netlists, you want to go to the PCB layout. This is my PCB layout. I tend to use ground planes because I'm too lazy to route all the grounds properly, and it just makes life easier. I suppose it amounts to the same thing in any case. So basically it'll give you all your components. You can drag them around, move them, rotate them, connect them with tracks here. You can edit their footprints. Will one of these let me? Change footprint. I'm using LEDs footprints for the jumpers just because I know it's right. It's a bit lazy, but it works. Their library is quite complete though. It's just it didn't have a footprint for the jumpers on the Linux version I designed this in, which was odd, but I suppose that's life. Let me just take away the ground plane so you can have a look. I do have some ground wires here, and I had to use these specific transistor footprints, even though my transistors are, free in line, just to keep within the design rules that Seaboard specified. But they did drill my holes properly. I was quite happy with the 3mm holes and everything. And just have a look. Ooh, let's hide this PCB. And let's hide the schema. And this is my PCB. You'll notice that they drilled the holes different sizes, so their hole finding software isn't terrible, but it's not really that great. Anyway, close enough. The chip will fit. There'll be no issues as a result of that. So yeah, I've got 2 of these. The other thing KiCad allows you to do is get that up. Is it'll then draw a nice 3D render of your board, and if we go and look at the bottom, we can see all the solder points, and you can rotate it around and you can look at everything. And technically speaking, maybe I should have had this facing the other way, but it doesn't really matter. There's not much heat dissipation on this board anyway, if all things go right. And that jumper point there isn't ideal, but it's close enough. Again, most of these things are close enough. This whole section here, by the way, may or may not get populated. It was an afterthought in a hurry just to see. The one LED probably will get populated. The other one, we'll see. If you go underneath and you have a look, you'll notice that one's not an LED, it's a jumper. I'm forgetting my own design. Anyway, so that's the entire process I went through to design the PCB. I didn't film it because I was doing it under Linux. I'm used to using KiCad under Linux. So always have, probably mostly always will. I suppose it runs quite well in Linux, in Windows, so there's no harm in it. My PCB is far from optimized. I think I could probably gotten it smaller and better, but you know what? I figured this is good enough. This'll do the job that it's intended to do. So that's basically the system. We've got mounting holes. I'm going to try and get some motherboard stands, like you get on a computer, to mount the thing in. We've already taken the UPS apart. We have, in fact, the battery right here. All the components work in isolation. So the idea now next is next video I'll probably solder this together, and I'll build out the system, probably mount everything directly into the UPS casing, because I'm just going to assume everything's going to work, because what could possibly go wrong? But I am waiting for fuse holders before I can proceed too far in this. I've done the measurements on the CPE and the router, looking at about 600 milliamps for both. I think that should be fine. Should give me about 10-11 hours. I may have a LED that comes on to give ambient light, a warm white super bright, when the power fails. It's a bit interesting because, you know, there's always a potential for running the battery flat, but you know, 20 milliamps, if I have 3 LEDs in series, 20 milliamps is, you know, if there's 1 amp hour left in the battery, if I set the protection voltage up a bit, it'll probably last a fairly ridiculous amount of time, because the slower you discharge a lead acid battery, the more capacity you can extract from it. So it probably won't be too bad. I suppose if I go away, I might just disconnect the whole system just for safety if I'm away for an extended period. But anyway, that's the whole system. So have fun and enjoy until next time. Cheers.